this class I am going to start a new chapter, that is earth pressure or the lateral earth pressure. Now, what is lateral earth pressure? When we are constructing any type of geotechnical structure, where that we have to resist some soil or earth, then that earth will give you a pressure. Okay. So, that pressure we are talking about the lateral earth pressure. If you look at this figure here, this here this is the wall or a structure which is supporting this soil. Okay. So, this side is soil or it is called backfill. Okay. And this side there is nothing. So, this soil will give you a pressure on the wall. So, that pressure is called the earth pressure. Now, this earth pressure can be three types. Okay. So, this earth pressure, one can be at rest. So, earth pressure can be three types. It is at rest. What is at rest? At rest means this structure or the wall. So, this is a, if I say this is a rigid wall. So, this wall is not moving. What is the that means when you are, this soil is applying stress on this wall. So, wall is so rigid that it is not moving. So, there is no movement in the wall. So, it is at rest condition. So, in that condition, the earth pressure that is applying on the wall is called the earth pressure at rest. Okay. So, that means there is no movement of the wall. And the second one is active earth pressure. What is active earth pressure? Now, when this soil is giving a stress or the pressure on the wall, so this, if the wall moves in this direction. Okay. So, the direction means direction to the direction of the force, because your force direction is this way, wall is also moving in that way. So, in that portion of earth pressure is called the active earth pressure. And there is a third type of earth pressure which is called, there is the passive earth pressure. Okay. Now, what is passive earth pressure? Now, if you that here direction of force is here, this direction as usual, because this is the backfill, okay, or soil, and the soil is giving pressure on the wall, but your wall is moving this direction. This is the wall movement direction. Okay, and this is the pressure direction. Okay. So, that means, if your wall moves opposite to the direction of the force, then it is called the passive earth pressure. So, there are three types of earth pressure. One is earth pressure at rest, that means, wall is so rigid, it is not moving any direction. So, that is at rest. Then, if the wall moves towards the direction of the force, that means, this is the wall movement direction, and this is the force or pressure direction. So, it is moving towards the direction of the force, then it is called active earth pressure. If wall moves towards the opposite to the direction of the force, that is called passive earth pressure. In other way, active and passive force can be defined as that if your wall moves away from the backfill. So, this is the backfill, wall is moving away from the backfill, then it is called the active earth pressure. If your wall moves towards the backfill, this is the backfill, it is wall is moving towards the backfill, this is called the passive earth pressure. Now, you can see that at rest, the pressure when this wall is subjected to from the soil and the pressure where wall is subjected to during the active will not be same, because at rest condition wall has to be very rigid, because it is this force you have to resist such that there will be no movement. But in the active condition wall is allowed to move. So, that means some stress is released. Okay? So, your pressure at rest condition is more than the pressure at active condition, because at the active condition you are allowing wall to move away from the backfill or towards the direction of the force. So, your pressure is released, because you are applying some movement. Okay, but at rest condition you are not applying any movement. So, you have to resist the full pressure which is acting, which is coming from the soil. So, at rest condition your more pressure is acting as compared to the active condition. But if it is a passive condition, then the wall is moving towards the backfill. So, that means it is opposite to the direction of the force. So, the pressure that is applied on the wall is greater than even the at rest condition, okay, because it is towards the direction opposite to the direction of the force. So, that means your active earth pressure is the lowest earth pressure the wall is subjected to, then at rest, then passive. So, I can write that your passive earth pressure is greater than at rest, is greater than active. Okay. So, active will give you the lowest earth pressure, then at rest, then passive. Okay. So, if you look at this figure, this middle figure, here also you can see that this is the x axis is the wall movement, okay, and y axis is the pressure which is acting on the wall. So, you can see this is the wall movement for the active and this is the pressure which is lowest. So, and there is the amount of wall movement, this is the amount of wall movement del x for active. Okay, this amount of wall is moved due to the active pressure, or to develop the full active pressure you need this much of the wall movement. And then the at rest you can see there is no wall movement, your wall movement del x is 0, but this pressure at rest condition is greater than the active. And then the passive you can see this passive force is maximum and you need this much of the wall movement x delta x p, this is delta x or delta x a. So, you can see from this figure also that your delta p or delta x p is greater than delta a, which means that to develop this full passive force you need more deformation compared to develop the full active force. Okay. So, that means the active force deformation is, or the active stage deformation is lower than the passive stage deformation. Okay. So, that is the or wall movement. Okay. So, that means here this is the away from the backfill, this is the towards the backfill which is passive, away from the backfill which is active. Okay. So, now these are the three pressures: active, at rest and passive. So, we will discuss one by one all these three pressures, how we will calculate these three pressures, okay, on a retaining wall or the earth retaining structure. The first is the active, first is the earth pressure at rest. Okay. So, now if this is the strain, okay. This is the strain epsilon x is the strain of a horizontal direction at depth z of an element. Suppose this, if this is the element, so we have a strain at the horizontal direction of an element, and then let the Poisson ratio and the elastic modulus is mu and E, then the earth pressure at rest corresponding to that strain 0 lateral earth strain will be the earth pressure at rest. Okay. So, that means here if I write this expression, this is the strain expression, this epsilon x is the strain expression and this sigma are the stress. Okay. So, this is x y, because this is the retaining wall problem or earth pressure theory, which is plane strain problem. Okay. So, plane strain problem. So, that is why we are taking x, x, y, z. So, these are the three stress component that we are considering, that sigma x, sigma y and sigma z. So, this is the expression. So, I am not deriving this expression. You will get this expression from any standard book, that what is the expression of x. So, in terms of E and stress. So, strain expression in terms of E and stress. So, now when this strain is 0, so your sigma x will be this. Okay. So, this will be the mu 1 minus mu sigma z. Okay. If the your strain is equal to 0. Now, this the way we can determine that earth pressure coefficient. Now, if I write that sigma x by sigma z is equal to mu 1 minus mu, and sigma z will be the earth pressure at, sigma x will be the earth pressure at rest. Okay. So, I can write that sigma z is the at any point gamma into z. Okay, that is the vertical stress which is acting. So, I can write that the k sigma x is equal to k into or k 0 into sigma z. Now, this is the earth pressure at rest, which is k 0 into gamma into z. This k 0 is called coefficient of earth pressure at rest. Okay. So, this is the coefficient of earth pressure at rest. So, which we can calculate by mu 1 minus mu. If you know the mu, we can determine what would be the coefficient of earth pressure at rest. If I know the coefficient of earth pressure at rest, if I know the unit weight of the soil, so at any depth we can calculate what will be the earth pressure at rest condition will act in a wall or in a earth retaining structure. Okay. So, we can write the similar thing is explained here, that this is the vertical stress is acting at any element, okay, sigma z, and this is sigma x. A bar means it is in terms of effective stress. Okay. So, that means here your P 0 is equal to k 0 into gamma into z or gamma bar into z. So, if it is linearly varying with z, because if z increases, because this is constant if it is a homogeneous soil, and k 0 is also constant for a soil. So, it is a function of z. So, we can write that at any, if your z is equal to h. So, we can write k 0 gamma dash into h. Okay. So, the force that will act P 0, this is small p 0 is the stress. So, total force will be the area of this triangle. Okay. So, this area of this triangle will be p 0 is the half into this base k 0 gamma dash h into this height h. Okay. So, finally, we can write half k 0 gamma dash h square. Okay. That is the thing, half k 0 gamma or gamma dash h square. Gamma means there is no water table, and gamma dash this in terms of effective stress, or we are talking about, we are considering the water table effect. Okay. And remember that this p 0 act at a height of h by 3 from the base of the wall, okay, or the retaining structure. So, that is the h by 3 from the base. So, this way we can calculate the earth pressure and the earth force due to the this lateral earth pressure at rest condition. So, these are the some k 0 values which is given for the dense sand 0.04 to 0.45, loose sand 0.4525, this compacted mechanically compacted sand means it is compacted, and 0.8 to 1.5, normally consolidated 0.5 to 0.6, over consolidated clay 1 to 4. And another way, one expression is k 0 expression is, you know that k 0 expression is mu 1 minus mu, mu is the Poisson ratio. Another way also, Jockey 1944, he has given one expression that if you know the phi value of the soil, you can also calculate the k 0, that is 1 minus sin phi. So, either you can use this expression or this expression to know the k 0 value, or if you have this table, from this table also you can get the k 0 value if you do not have any mu value or the phi value available. But these, if these values are available, you can use either this expression or this expression to calculate the coefficient of earth pressure at rest. Okay. And once you know the k 0, then you can calculate what is the pressure and the force is acting on a retaining structure, earth retaining structure. So, next one that we will discuss about the active and passive earth pressure. So, there are two theories which are very popular. The first one is the Rankine's theory of earth pressure. Okay. So, there are some assumptions behind these theories. So, the first assumption is backfill is isotopic, homogeneous and the cohesionless. So, the backfill means the soil which is retained by the earth retaining structure. So, that soil is cohesionless. Okay. Initially, earth pressure theory proposed by the Rankine, where the soil is cohesionless. Okay. That means, C value is 0. Okay. And this is homogeneous, there is no layer soil, it is homogeneous, okay, and it is isotropic. And then the soil in its state of plastic equilibrium during the active and passive pressure condition. So, it is in the equilibrium condition. Okay. And the rupture surface is planar surface, which is obtained by considering plastic equilibrium soil of soil. So, rupture surface is planar means if this is your wall. So, when this wall moves either this direction or this direction, so this portion of the soil, if suppose if this wall moves this direction, so what will happen? This portion of the soil will also move, and there is if this wall moves excessive amount, then this soil will also fail, okay, because it is moving, this soil will also try to fail. So, this failure surface, it is assumed is planar. Okay. This is the ground surface. So, this is the rupture surface or the failure surface. So, it is as per Rankine, it is assumed that this failure surface is linear. That means, if the soil moves in this direction, so this portion of the soil within this wedge will also try to fail along this surface. Okay. So, that is the failure surface is linear, and backfill, this is horizontal. Okay. This is the backfill, this is perfectly horizontal, and backfill wall is smooth, okay, and is vertical. So, that means this is the wall that is also perfectly vertical and this is smooth. Smooth means the friction between the soil and the wall is 0. So, that means here delta value is equal to 0. Okay. So, delta value is friction between the soil and the wall. So, that is also assumed as a 0. So, that means what are the assumptions? Your backfill surface is perfectly horizontal, it is a planar failure surface, wall is perfectly vertical and it is smooth. That means delta value is 0, friction between the soil and the material is 0 and the soil is in plastic equilibrium and backfill is cohesionless, that means C is equal to 0 and the soil is also homogeneous. Okay. So, these are the assumptions against the Rankine's theory. So, again this is the two cases as I have discussed, one is active, one is passive. So, you can see this is the deformation of active case is less than the deformation of the passive case. Now, we will discuss about the active and passive cases. So, this is the two cases, one is active, another is passive. So, I will discuss in terms of your Mohr circle, that first we will talk about the active case. Okay. So, it is the active case or active earth pressure. Okay. So, suppose this is a wall and you have a element here, okay, or you can say that element is on the wall and here this is sigma z, this is sigma x and this is this direction and this direction also there is a element. Now, when active condition means that as the wall away from the so, this is very important that as the wall moves away. So, now if I take the element, so this is sigma z sigma x, because this is the z axis, this is the x axis. Okay. This is x, this is z. So, as wall moves away from the backfill, what will happen? This element will expand, okay, and the sigma x value will decrease. And as I mentioned that sigma x means lateral earth pressure and if it is at rest conditions, more pressure is acting and as you are allowing some deformation. So, pressure will be released. So, the same thing, this pressure will be released. So, now if you look at this figure, here it is in active case, it is expand. So, this pressure on this wall will release. Okay. So, now if I draw a Mohr circle here, so we are drawing a Mohr circle, this is sigma x and this one is tau, okay, or this is sigma vertical stress and this is the normal stress, shear stress. So, this is shear stress, this is normal or vertical stress axis. Okay. And you can see in this element there is no shear stress is acting. Okay. So, that means all the vertical stresses are principal stresses. So, what is principal stresses? Principal stresses means a plane, if your shear stresses are 0, then the normal stresses that is acting on that plane is called the principal stresses. So, these all are the principal stresses, because your shear stresses is shear stresses are 0. Okay. So, now at suppose at rest condition your this element is at rest condition. So, this will be the Mohr circle at rest condition. So, this is your, this will be the sigma x and this will be sigma z. Okay. This is sigma z and this is sigma x. So, and this is the Mohr circle, and this is, if this is the Mohr Coulomb envelope, that this angle is phi. Now, this is the Mohr circle at rest condition. Now, your wall starts moving. Now, if it starts moving at a point, your sigma z vertical stress, that will not change. Sigma stress sigma z is constant, okay, because at a point your sigma z is suppose gamma into z. So, that will not change, it is constant, but your sigma x, that the lateral stress, that will reduce. Okay. So, next Mohr circle will be, because it is sigma x reduce means your sigma x point will shift towards the origin, because it is reducing, and sigma z will remain same. So, the next Mohr circle will be something like this. This is the, and this is the sigma x is changing, and sigma z, because sigma z is constant and sigma x is decreasing. Okay. Sigma x is decreasing. So, there will be a situation when your Mohr circle will touch this envelope. That means, that is the limit, because after that, because any Mohr circle will not cross this line, because this is your failure envelope. So, if any Mohr circle touches this line, means there is a failure. So, remember that any Mohr circle will not cross this line. So, this is, so that means there will be a limit or minimum value of sigma x, at which your full active stress or active condition is developed. After that, there will be failure, okay, because as I mentioned, it is in equilibrium condition. So, we are just considering it will not fail, just it is in equilibrium condition. So, the Mohr circle, this is the lowest sigma x value, that is the minimum sigma x value. So, you cannot get a sigma x value minimum this value, because your Mohr circle touches the line, because it cannot go above this line, because any Mohr circle will not exist above this line, remember that. So, and you can see I have drawn a half circle, you can draw the full circle the similar way, this will be the phi. So, you can complete this full circle also, and this will also touch this line. Okay. You can complete the full circle. So, this is the sigma x minimum. Okay. And as I mentioned, so at this condition all the stresses are the principal stresses. So, I can write in this way that this is my sigma and this is the tau and this is the failure envelope phi, and this is the lowest sigma x. So, I am writing sigma 3 and this is sigma 1. Sigma 1 and sigma 3 are the principal stresses. Okay. So, these are all principal stresses. So, I can write that your sigma z is equal to sigma 1 and sigma x is equal to sigma 3, because these vertical stresses are principal stresses. So, this is the point I have written. So, if this is the center O and if I draw a line here, definitely it will be 90 degree, because this is the tangent over this point and we are joining this point and the center. So, this will be 90 degree, because this failure line envelope is the tangent. Okay. Now, if I join this point and this point, so this dotted line, this line will give you the direction of the failure surface or the rupture plane. So, this is the direction of failure plane. Okay. So, say that direction, this angle is theta. Now, what is this angle value? Because you can see that if I am considering O, if this is your O, this is C and this is A, this point is A. So, now from triangle OAC, I can write this angle is equal to, because this is phi, this is 90 degree. So, this angle will be 90 degree minus phi. Okay. Because if you take this triangle, this angle is 90 degree, this angle is phi. So, this will be 180 degree minus 90 degree minus phi. So, this angle will be 90 degree minus phi. Now, if I take this triangle, so this is a B, this point is B. So, now if I take triangle ABO, then if this is theta, this will also be theta. Okay? Because this is this side and this side are same, because both are the radius of the circle. So, this side as your OA is equal to OB, because both are the radius of this circle. So, this will be both the angles will be theta. So, I can write that 90 degree minus phi plus 2 theta will be equal to 180 degree. Okay. So, your 2 theta will be 90 degree plus phi. So, theta will be 45 degree plus phi by 2. Okay. So, it means that the failure line will make an angle 45 degree plus phi by 2 with the horizontal. So, now if this is your say wall and if there is a rupture angle, active stage. So, this is your failure plane. So, it will make an angle 45 degree plus phi by 2. This is for active case. So, for the active case, your failure angle, this theta will make an failure plane will make an angle 45 degree plus phi by 2 with the horizontal. Okay. So, the next class I will discuss about what would be the stress, active stress acting on a earth retaining structure, and what would be the failure angle if there is a passive case. Okay. And I will also discuss how we will calculate the passive earth pressure considering or with the help of this Mohr circle. Thank you.